Now let's move on to the next type. Here we prove an asked equation using the given equation. Most of these problems have words like if and show that, and also have a somewhat similar solving method, like equating the entire equation to a single constant, like k. For the first problem we have, if log of x upon a into b minus c equals log y upon b times c minus a equals log of z upon c times a minus b is true, then we need to show that x times y times z equals 1. The first thing we do is equate the entire given equation to a variable, k. And then take each part of the equation separately, and equate them to k. Next, we take the entire denominator to the right side, to get log x equals k times ab minus ac. We do this with the other two parts of the given equation also, to get log y equals k times bc minus ba, and log z equals k times ca minus cb, and marking all new equations as 1, 2, and 3. Now we add the equations 1, 2, and 3 to get log x plus log y plus log z equals k times ab minus ac plus bc minus ba plus ca minus cb, in which ab and ba will cancel out, then ac will cancel out ca, and lastly, bc will cancel out cb, leaving only 0. This 0 is to be multiplied with k, which obviously comes to 0. And since we know log of 1 is always 0, we replace 0 with log of 1. And for the left side equation, we apply log of product to get log of x times y times z equals log of 1. Now we remove the log on both sides, or we can say we took anti-log on both sides. Either of these statements is acceptable. So the result we needed to prove is hence found, and we have x times y times z equals 2, 1. The next problem is also somewhat similar to the previous one, but we're still doing it. To understand how to approach problems of the same nature. If we have log of x upon b minus c equals log of y upon c minus a equals log of z upon a minus b, then we have to show that x to power b plus c times y to power c plus a times z to power a plus b equals 1. As usual, we will consider the entire given equation to be equal to a constant, k. And as usual, we multiply the denominator to k, to get log of x equals k times b minus c, log y equals k times c minus a, and log of z equals k times a minus b. Now in the previous problem, the answer came to us mechanically. We just kept solving, and it kept working, but in this one, we need to make a tweak of our own. To make it work, we need b plus c, c plus a, and a plus b. For that, we need to multiply b plus c to log x, and since we respect the property of equal ratios, we also need to multiply b plus c to the denominator. Similarly, we will multiply c plus a to log y and a plus b to log z, which gives log x to power b plus c equals k times b squared minus c squared, and log y to power c plus a equals k times c squared minus a squared, and log z to power a plus b equals k times a squared minus b squared. And we will mark these three as equation number 1, 2, and 3. Now we add these equations, which leads to log x to power b plus c plus log y to power c plus a plus log z to power a plus b equals k times b squared minus c squared plus c squared minus a squared plus a squared minus b squared, in which b squared will cancel out b squared, c squared with c squared, and a squared with a squared. Remaining k is now to be multiplied with 0, which obviously leads to 0. Since we know that log of 1 is 0, we can replace 0 with natural log of 1. And we use log of product on the left-hand side of the equation to get log of x to power b plus c times y to power c plus a times z to power a plus b. And as our final step, we will remove log on both sides to get the original statement that was asked in the question. That is, x to power b plus c times y to power c plus a times z to power a plus b equals 2, 1. Next problem presents itself as, if log of x upon 2 equals log of y upon 3 equals log of z upon 5. Then, we need to show that x to power 8 equals y squared times z squared. As usual, we take the entire given equation and equate to a constant, that is k. We take 2 alongside the k, making it 2k. Now we multiply both sides with 8, because reflecting back on the question, we see we need x to power 8. And we use log of power later to get log of x to power 8 equals 16k. We will mark this as equation number 1. Similarly, we take second part of the given equation, and the only thing different we're going to do is multiply on both sides with 2, and from this, we yield log of y squared equals 6k. And we mark it as equation number 2. And for the last one, we again do the same mechanical process and multiply with 2 and yield log of z squared equals 10k. And mark this as equation number 3. Now we add equations 2 and 3 and get log of y squared plus log of z squared equals 6k plus 10k. Now we use log of product on the left-hand side of the equation. We get log of y squared times z squared, which equals 16k. And the thing we need to observe here is equation 1, that is, log of x to power 8 is also 16k. So we can make the subtle connection and get log of y squared times z squared equals log of x to power 8. And for our final move, we remove log on both sides to get our answer, which is x to power 8 equals y squared times z squared. The next one is a really interesting question. If log of x upon 2 equals log y upon 3 equals log z upon 5, then this question seems already familiar to the previous one. But wait, the question isn't finished yet. This question we need to prove x times y equals z. Now that the given condition is the same, an asked equation is different. Let's see how our approach differs from the previous problem and how easy or difficult does it make the question to solve. As we start, we take the given equation and equate it to constant, k it is. And as usual, we take the first part, log x upon 2 equals k. And we take 2 on right side, giving us log of x equals 2k. And we will mark this as equation number 1. Observe that we didn't multiply or manipulate the equation because the equation asked doesn't have such needs. It's just x and y and z. And just like that, we solve the other two parts. Log of y upon 3 equals k becomes log y equals 3k and will be marked as equation number 2. And log z upon 5 equals k becomes log z equals 5k and is marked as equation number 3. Now we add equation number 1 and 2. And we decide to add these because of what is asked in the question. What we get is log x plus log y equals 2k plus 3k. And after using log of product, we get log of x times y equals 5k. And we do observe that log of z also equals 5k, so we equate log z to log of x times y. And after that, we remove log on both sides to get our asked equation, that is, x times y equals z. The next example states, if log of a plus b upon 3 is equal to 1 upon 2 times log of a plus log of b. Then we need to show that a squared plus b squared equals 7ab. Solving this one wouldn't require the usual method, meaning we won't be needing to equate the given equation to constant k. First, we take the 2 from right to left side, making it 2 times log of a plus b upon 3. And for what remains on the right side, we apply the log of product there, giving us log of ab. Now, we use log of power to take the 2 on left side as a power of log of a plus b upon 3. Now we remove log from both sides, leaving us with only a plus b upon 3 squared equals ab, which further gives us a squared plus 2ab plus b squared upon 9. This 9, further we will be taken on right side, to get 9ab. Now we move the 2ab to the right side, which will yield out the answer as a squared plus b squared equals 7ab. The next question has a bit of deja vu feeling to it. If a squared plus b squared equals 7ab, then show that log of a plus b upon 3 equals 1 upon 2 times log of a plus log of b. Deja vu, right? It is not only to confuse you, but to get the concept backwards. Remember, we gotta move like the queen piece, and to do that, we need to solve equations, not just in one direction, but any way imaginable. To solve this, we have to add 2ab on both sides of the given equation. This is the only specific manipulation we must note because sometimes it's better to make a path instead of finding one. We get a squared plus b squared plus 2ab equals 7ab plus 2ab, which further gives us a plus b whole squared equals 9ab. We will take this 9 to the left side, where we will take it inside the whole square, which will make it a plus b upon 3 the whole squared. After that, we apply log on both sides now. And we use log of product on the right side and log of power on the left side, giving us 2 times log of a plus b upon 3 equal log of a plus log of b. Now we just make a little adjustment. We take the 2 to the right side to finally get the equation that was asked in the question, that is, log of a plus b upon 3 equals 1 upon 2 times log of a plus log of b. This problem is also a bit different. It states, if x equals e power y minus e power negative y upon e power y plus e power negative y, then we must show that y equals 1 upon 2 times log of 1 plus x upon 1 minus x. This log has base e as we know already. We don't need to equate this to a variable like k, as there is only one equation, unlike previous problems where we had multiple given equations. Let's use laws of indices and turn those negative y's to positive. Now we multiply e power y to balance the entire equation. We get e power 2y minus 1 upon e power y upon e power 2y plus 1 upon e power y, where e power y cancels out each other. And to the remaining equation, we use invertendo, meaning we place numerator in denominator and denominator to numerator. As there is nothing to the denominator of x, we take it as 1 and get 1 upon x. Now we use componendo, and dividendo, where componendo adds denominator value to the numerator, in the numerator, and in dividendo, we subtract numerator from the denominator, in the denominator. Which leads to 1 plus x upon 1 minus x on the left-hand side. And on right side, e power 2y plus 1 plus e power 2y minus 1 upon e power 2y plus 1 minus e power 2y plus 1. Where 1 in the numerator and e power 2y in denominator gets subtracted out. With 2 times e power 2y upon 2. In which further, 2 cancels out each other. And by converting to log, we get log of 1 plus x upon 1 minus x equals 2y. And with just taking the 2 to left side, we get our desired equation, that is, y equals 1 upon 2 times log of 1 plus x upon 1 minus x.